Okay, dear students, mm, welcome to the part 6 of the organic chemistry chapter. Today, I'll be trying to complete this chapter, and the topic which is left over here is alkynes. Alkynes. Okay, now what are alkynes? Alkynes are a homologous series of these are a homologous series of unsaturated hydrocarbons that contain carbon-carbon triple bond. Alkynes. Okay. The general formula of alkynes is CnH2n-2. Okay. The alkynes are also known as acetylene, ACETY, acetylene series. Okay. Now, now talking about the isomerism, isomerism in alkynes. Isomerism in alkynes. Remember, alkynes with 4 or more carbon atoms. Alkynes with 4 or more carbon atoms exhibit position isomerism. That is very important to understand over here. Now let me explain you this with the help of an example. One molecular formula I'll write down. That is the formula of butane, BUTYN, butane. The molecular formula is C4H6. Okay. So there are 4 carbon atoms. So 1, 2, 3, and 4. Butane, position isomerism. So what I can do is I can put triple bond here. So this becomes CH3. This becomes CH3. This one is what? 2 but 2 ion. Okay, numbering, if you number like this, but 2 ion. The same molecular formula can be written in another form also. Carbon 1, carbon 2, carbon 3, carbon 4. I can have the triple bond first and the second carbon. So here it can be like this. Here it will be CH2 and here CH3. So this is but 1 ion. So these are the two isomers, and these isomers are called position isomers. Why position isomers? Because the position of the triple bond is changing. Okay, it is different. Now, in our syllabus, under this heading alkynes, please remember, under this heading alkynes, our syllabus demands from us the study of ethyne or acetylene. Ethyne or acetylene. The formula is like this. This is ethyne or acetylene, the structural formula. Now moving ahead to the laboratory preparation. Laboratory preparation of ethyne. The first one is from calcium carbide. CaC2. Now the reaction. To prepare ethyne, we need calcium carbide and we need to react this calcium carbide with water. So I'll write the equation in this manner. Calcium carbide, like this. Now It is treated with water, okay, in a say round bottom flask, okay, and then the reaction happens between calcium carbide and water, okay, and what is formed over here? The products formed are calcium hydroxide and ethyne C2H2. This is a gas. Now this gas, it is collected over water. Remember, ethane gas is collected over water by downward displacement of water. It is slightly soluble in water. The purification of this gas, purification of ethyne, it is done by passing first through water. Purification is done by passing first through what? Water. Okay, and then through acidified potassium dichromate, and then through acidified potassium dichromate, K2Cr2O7, acidified potassium dichromate. Now this water and potassium dichromate remove the impurities like phosphine, hydrogen sulfide, okay, ammonia gas. So these impurities needs to be removed to collect pure ethyne gas. This was the first laboratory method of preparation of ethyne from calcium carbide. Now my dear students, calcium carbide, it is available in the general stores also. It is available if you go to any general store and ask for carbide, or you have to ask for carbide, they will give you calcium carbide only. Now bring it home and then wrap it in a newspaper. It is like irregular stone shaped, white colored, dirty white colored compound, okay, and then put that calcium carbide in a container or in a carton, containing unripe fruits, and keep it overnight. The next day you will find that the fruits have ripened, they have become ripe, so it is used in the artificial ripening of fruits. This reacts with the water vapor which is there from the fruits, and ethyne is formed, which helps the fruits to ripen at a faster rate, okay. Now the second method of preparation of ethyne. Ethyne can be prepared by a reaction which is called dehydrohalonation reaction. Dehydrohalonation of 1,2-dibromoethane. 1,2-dibromoethane. So we can prepare ethyne gas by the dehydrohalonation of 1,2-dibromoethane. The reaction is important over here. So what I am doing is I am taking 1,2-dibromoethane like this, in this manner. BrHC. This is 1,2. This compound is 1,2-dibromoethane. Okay. So this is reacted with potassium hydroxide. Alcoholic. Don't use aqueous. You have to use alcoholic. And upon boiling this mixture, ethyne gas is produced along with potassium bromide and water. Okay, so this is the second method of preparation of ethyne. Now, going to the physical properties. Physical properties of ethyne. Physical properties of what? Ethyne. The first one is ethyne. It is a colorless gas. Remember, it is a colorless gas. It gives a sweet smell when pure. Okay. Otherwise, ethyne has a garlic odor and color. It is almost insoluble in water. It is slightly lighter than air. Okay. These are the physical properties of ethyne. Then, moving on to the chemical properties. Chemical properties of ethyne. Chemical properties of ethyne. The first one, it is combustion. Combustion. A burning of ethyne in air. Now remember, ethyne burns in air with a luminous sooty flame. It illuminates, luminous sooty flame to form carbon dioxide and water, liberating a large amount of heat, which means the reaction is exothermic. So, equation is necessary over here. 2C2H2 plus 5O2, okay, it forms carbon dioxide and water vapor plus heat. Heat is given out, okay. The next one is the second chemical property which ethyne undergoes is addition reactions. Addition reactions. Now, under addition reactions, remember ethyne, just because it has a carbon-carbon triple bond, the triple bond can be broken down into double and double can be broken down into single. That is why it can easily undergo addition reactions. Addition reactions are characteristics of unsaturated hydrocarbons. Okay. Now, over here under addition reactions of ethyne, please keep in mind, first one is addition or reaction with chlorine. Reaction with chlorine, you can say gas. Now this chlorine gas, it is dissolved in carbon tetrachloride, which is the medium, and then ethyne gas, it is passed through it in this manner. Okay. CCl4. So it forms this compound 1,2. This what it is 1,2 dry. What do you call dye? 1,2 dichloroethene. There's a double bond over here. Okay, there's a double bond over here. It is called 1,2 dichloroethene. Okay, 1,2 dichloroethene. Now this 1,2 dichloroethene, CHCl, double bond CHCl, it further reacts with the chlorine in the solvent, and then it forms, over here HCCl, Cl, and H. This compound is formed finally. This compound is called 1,1,2,2 tetra. Tetra. There are 4 chlorines, It is 1,1,2,2 tetrachloroethane. Okay, that is how ethyne reacts with chlorine. 2 steps. Similarly, we can have reaction for bromine also in the same manner. Okay. The reaction with iodine is there, but iodine reacts very slowly with ethyne in the presence of alcohol and forms 1,2-diiodoethane. Okay, the reaction is slow. It is not so important. Now, next one is, if you look at the next one, number B, okay, reaction with hydrogen. That is important. Reaction of ethyne with hydrogen, So that is hydrogenation. But this reaction happens in the presence of a catalyst, addition of hydrogen. If I write the formula of ethyne plus H2 in the presence of nickel, catalytic hydrogenation at 300 degrees Celsius, what do you get? We get first ethene. This one is ethene, double bond, containing a double bond. Here it is ethyne, triple bond. Further, you react this ethene with again hydrogen, nickel catalyst at 300 degrees Celsius. It forms, what does it form? It forms ethane. Okay, that is how ethyne reacts with hydrogen in the presence of catalyst. It is called catalytic hydrogenation. Okay, now Next one, number C. Look at the third chemical property of ethyne. Ethyne reacts with hydrogen chloride also. Okay, so here reaction with hydrogen chloride. Hydrogen chloride. Reaction with hydrogen chloride over here. Remember, ethyne reacts with an aqueous solution of hydrogen chloride called hydrochloric acid. Okay, that is hydrochloric acid. So this reaction is important. Try to make a note of that. Now, why it's important, I'll let you know in a couple of minutes. So this is ethyne plus hydrochloric acid. Aqueous solution of hydrogen chloride is hydrochloric acid. So it forms CH2 double bond CHCl. This compound is called vinyl chloride. Vinyl chloride, or monomer of polyvinyl chloride. This one unit is called vinyl chloride. It is a monomer. If you take lot of vinyl chlorides together and allow them to undergo condensation, it will form polyvinyl chloride. Polyvinyl chloride, we call it in short PVC. Okay. Now, this vinyl chloride, if you take this vinyl chloride, this one CClH, it will further react with aqueous hydrogen chloride gas. It forms again 1,1-dichloroethane. Forms 1,1,1,1-dichloroethane. It is a very special reaction. Both the chlorine atoms attaching on the same carbon. Okay, so this compound is nothing but it is 1,1-dichloroethane. Okay, so this is number C, the third chemical property of ethyne. Then number D. Number D is important. Okay, number D is very, very important. Please remember. Number D is important. It is an indirect, you can say, chemical test for ethyne also. Now, number D, it is a reaction which is called reaction with ammonical, A-M-M-O-N-I-A, ammonical silver nitrate solution. Silver nitrate and ammonical copper 1 chloride solution. Okay, this reaction is very, very important. It is very, very important as a test for ethyne gas. Okay, now over here the first reaction, if I take ethyne, and react this ethyne with ammonical silver nitrate in ammonium hydroxide. This one is ammonical silver nitrate. Okay, so the reaction happens Ag, C, Ag. This is what? This is silver acetylide. Silver acetylide. And this silver acetylide, it is a white PPT test. Okay, so if you are given two gases, say one is ethyne and the other one is maybe ethene or ethane. So to distinguish these gases from ethyne, the other gases will not give a white precipitate with ammonical silver nitrate solution, but ethyne forms a white precipitate of silver acetylide with ammonical silver nitrate solution. Here the other products are ammonium nitrate and water. Okay, that is reaction with ammonical silver nitrate solution, ethyne, giving a white precipitate. Please try to remember the observation over here. The next one, the second test over here is reaction of ethyne with ammonical copper 1 chloride solution. So for this I want to use another slide. Ethyne plus HuCl plus ammonium hydroxide. Okay, very important reaction. So we get acetylide, copper acetylide plus ammonium chloride plus water. This is what? This is copper acetylide, and color is good one. It is a red precipitate. Okay, ethyne with ammonical cuprous chloride gives a red precipitate. Remember that. And ethyne with ammonical silver nitrate gives a white precipitate. So these two reagents, ammonical silver nitrate and ammonical, copper 1 chloride, cuprous chloride, are very important reagents which can help to detect the ethane gas. Okay, so please remember these two equations as well. Okay, direct questions. Now the chemical properties of ethane is just over. Okay, now uses. I'll briefly tell you the important uses. Okay, ethane, it is used in oxyacetylene blowpipes, which are used in welding. They are used in welding. Number two, ethane is used in the manufacture of vinyl chloride, which is used to make the polymer which is called PVC. Just now I mentioned you that time. Okay. It is used in the manufacture of various organic compounds such as acetic acid, acetaldehyde, ethyl alcohol, and oxalic acid. Then number 4, ethane is used as an illuminant, illuminant in an oxyacetylene lamp or a torch. And most commonly use of ethane is it is used in the artificial ripening of fruits. Okay, so my dear students, the important part of this chapter is complete. Now this brings us to the end of this organic chemistry chapter. Please refer to the textbook to verify the chemical reactions from this chapter. Okay, and prepare accordingly for your final terms and the board examinations. Thank you so much.